So we're given this example, and this is example number 1, part A. And it says the following. It says, if the sine of theta is equal to negative 3/4 and if cosine of theta is greater than 0, find all 6 trigonometric functions of theta. Now, we already talked about how to do this by setting up ratios, and we're going to do that second. But I want to make sure that you can set this up also by using some of the trigonometric identities that we talked about. And what we're going to do is we're really going to focus for this example on the fact that anytime we have sine, if we can find cosine or figure out what it is, then we can figure out what all of the other trigonometric functions are going to be. And vice versa, if we know cosine, we can find sine and we can figure out the other trigonometric functions. And so really what we're going to focus on for this example is the fact that we know that sine squared theta plus cosine squared theta is equal to 1, and this comes from the first Pythagorean identity. Okay, so let's use this. We're going to use this trigonometric identity to help us, first of all, we're going to use this to help us find cosine based on the fact that we know that sine of theta is equal to negative 3/4. Well, if sine of theta is equal to negative 3/4, sine squared of theta is going to be negative 3/4 squared. Cosine is what we're looking for, so we're going to keep that as cosine squared theta is equal to 1. So let's do a little bit of algebra and let's figure out what cosine is. Well, we know negative 3/4 squared, negative 3/4 times negative 3/4 is 9 over 16. So we know 9 over 16 plus cosine squared theta is equal to 1. Now we're going to subtract 9 over 16 from both sides, and what this is doing is allowing us to get a cosine of theta by itself. We know cosine squared theta is equal to 1 minus 9 over 16. And if we want, we can rewrite this. It's probably wise to do this, finding a common denominator. So 1 is 16 over 16, and 16 minus 9 is equal to 7 over 16. So this is what we know so far. The cosine squared of theta is equal to 7 over 16. Now, to get cosine by itself, we can take the square root of both sides, and don't forget to put in your plus or minus anytime you take the square root. So we know that cosine of theta is equal to plus or minus the square root of 7 over 16. Let's do a little bit of simplifying here. Cosine of theta is equal to plus or minus the square root of 7 divided by the square root of 16, which is plus or minus the square root of 7 over 4. I know it's simplified in that manner that the denominator doesn't have any radical in it. All right, so we have two options here. We know that cosine of theta is equal to either positive square root of 7 over 4 or negative square root of 7 over 4. And there's a hint as to which one it is. And if you take a look over here, this is telling us that the cosine of theta is positive. So knowing that the cosine of theta is positive, we get rid of that negative solution. And now we know that cosine of theta is equal to the square root of 7 over 4. So remember what our ultimate goal is. Our ultimate goal is to find all 6 trig ratios. We know what sine is because that's what we were given. We know that sine is negative 3 over 4. We found cosine. We know that cosine is equal to the square root of 7 over 4. Once you know sine and cosine, you automatically know their reciprocals. We know cosecant is equal to negative 4 over 3. And we know that secant is equal to 4 over the square root of 7. And we're just going to rationalize that, which is 4 square root of 7 over 7. Now, the one that we don't know is tangent. But remember, from the identities, we talked about a quotient identity. And the quotient identity tells us that tangent is equal to the ratio of sine divided by cosine. So if we take our sine value and divide that by cosine, so we can kind of cancel out these 4's over here, the tangent of theta is equal to negative 3 over the square root of 7. Knowing that we know the cotangent of theta is just the reciprocal of that, which is negative square root of 7 over 3. And then we can kind of go back and adjust this because we can rationalize and get rid of the radical in the denominator. It's negative 3 square root of 7 over 7. So again, once you know sine and cosine, to find cosecant and secant, we just take the reciprocal. To find tangent, we just take the sine value and divide it by the cosine value. Once we get that, we can flip it and get the cotangent value. But again, as per my promise, I want to go back and solve this in another way. So we can use identities, but we can also use the ratios which we talked about a few sections ago. So let's take a look at this from one more lens. Now, if you're not interested in this, it's absolutely fine. You can pause it here. I just want you to know the answers are going to be the same. And it says the following. If sine of theta is equal to -3/4 and cosine of theta is positive, find all other trig functions. Now, remember when we talked about Princess SOHCAHTOA, we know that sine is equal to, sorry, make this a little better, sine is equal to opposite divided by hypotenuse. So one thing we could do is we could sketch it using right triangles. We also know that sine is the same thing as saying y over r. So we can figure out what this is equal to by using that ratio of y over r. Okay, so knowing that sine of theta is y over r, this is the same thing as saying, let me put this in blue, that our y value is 3 and, and that our r value is 4. Excuse me, our y value is -3 and our r value is 4. Now, we want to first figure out which quadrant we're in based on this information. So we know we're looking for a negative sine value, and we're looking for a positive cosine. Let's think about which trig function we're going to be in using all students take calculus. Excuse me, which quadrant we're going to be in using all students take calculus. Remember, in the first quadrant, they're all positive. In the second quadrant, sine's positive. In the third quadrant, tangent's positive. In the fourth quadrant, cosine's positive. So this is forcing us to be in the fourth quadrant because we know that sine is negative. So knowing that sine is negative, and we know that cosine's positive, so the only quadrant it could be in is this one over here, is in the fourth quadrant. So we're going to sketch this angle in the fourth quadrant. And again, we can construct a right triangle from it. And we know that our y value is equal to -3, and we know that our r value is equal to 4. Okay, so how do we find the x? Well, we can use the Pythagorean theorem. The Pythagorean theorem says x squared plus -3 squared is equal to 4 squared, which says x squared plus 9 is equal to 16. Subtract 9 from each side. We know x squared is equal to 7. To get x by itself, we're going to take the square root, and then don't forget our plus or minus. X equals plus or minus the square root of 7. And again, because our x value because this whole triangle is in the fourth quadrant, we know in the fourth quadrant our x values are positive, so we can ignore that. And we know that x is equal to positive square root of 7. So let's solve this using the fact that we know what the ratios are as well. Well, let's see. We started off with using the fact that sine is equal to -3/4. Sine is y over r. Now remember, the definition of cosine is that cosine is x over r. So the x value here is the square root of 7, and the r value is 4. So we know cosine is square root of 7/4. For the tangent values, we know tangent is y over x. So the y value is -3. The x value is square root of 7. And again, once we have these, we can quickly find the reciprocal trigonometric function. So we have cosecant of theta just by flipping sign. It's -4/3. We know secant of theta, and we're going to take the reciprocal, so it's 4 over the square root of 7. Rationalize it, and we get 4 square root of 7/7. And for the cotangent of theta, we get negative square root of 7/3, and then we can rationalize it over here as well by multiplying both sides by the square root of 7. We get -3 square root of 7/7. So if we take a look at the answers, we have exactly the same ratios here from each one, right? Sine, cosine, tangent, sine, cosine, tangent, same thing, cosecant, secant, cotangent, cosecant, secant, cotangent. And either way is acceptable, but I just wanted you to know another way in regards to how to solve this, specifically by using some of the identities.